So let's check this exam problem. A W2168 beam is 32 feet long. The beam is made of A992 steel, which has a yield strength of 50 kSI. The compression flange is braced at the end at interval of 8 feet. CB is 1 and phi MP is 600 feet kips. LP is 6.36 feet and LR is 18.7 feet. The surface loading results on 256 feet kips moment due to uniform loading live, and 80 feet kips moment due to point loads live, and 8.704 feet kips moment due to beam's self weight. What is most nearly the available moment strength, and is the beam adequate? We need to start first by calculating the ultimate moment based on these surface and dead and live moments. So the ultimate moments equal 1.2 moment due to dead load plus 1.6 moment due to live load. So it is going to be 1.2 multiplied by 8.7 plus 1.6 multiplied by 256 plus 80, which is going to be 548 feet kips. So the next step, here this beam is not mentioned in the table of the ZX which you have in the reference book. That's why, as you can see, it is already given the MP, the LP, LR, all of these values are already given to you because you don't have this values in the tables. So we have the LP which is 6.36 and we have the LR which is 18.7 feet, and we know that the unbraced length equals 8 feet. So this means that our value is between both the LP and the LR, which means we need to calculate for the lateral torsional buckling. The only missing parameter here which we don't have is the phi MR, but we know that the phi MR equals phi 0.7 if yield SX. So we need to obtain the SX. The SX is mentioned in the first table of properties of the sections, which is table 1-1. I'm going to show it to you now in the reference book. Here it is, this table of the properties, table 1-1. We need to find the beam W2168. Here it is. So we need to obtain SX, which is here. So our SX equals 140 inch cube. So this is the value of the SX. Let's go back to our problem. So referring to this table, we obtained the SX, which equals 140 inch cube. So we can directly now use this equation, which is phi MN equals CB multiplied by phi MP minus phi MP minus 0.7 phi F field SX, all multiplied by LB minus LP over LR minus LP. CB equals 1. Phi MP is given as 600 minus 600 minus 0.7 if phi equals 0.9. F field is 50 and SX equals 140 divided by 12 because this is in inches, and we are going to use the feet unit for the LB and the LP. This is multiplied by 8 minus 6.36 over 18.7 minus 6.36. Solving for this equation, you get that the phi MN equals 569 feet kips. This means that the phi MN is higher than the M ultimate, which means that the beam is adequate. So this is our answer here, which is 570 feet kips, and the beam is adequate. Thank you, and see you in our next video.